In a previous video, we introduced ourselves to one of Euclid's first circle geometry theorems, which dealt with lines coming from the center of a circle. And in this video, we're going to practice that. So in this question, we are given that O is the center of the circle. They tell us that OC is perpendicular to AB, so we can see that there's a 90 degree over there. AB, the length of AB is 8, and the radius of the circle is 5. Okay, so we can't see that on the diagram, but that's important. Question is, determine the length of OC. So what we can do typically is we can construct line OA, for example, so that'll look like this. And then we could say that AC, well, what do we know about the length of AC? Well done if you said it's 4, right? Because remember, we said that if you have the line coming from a center of a circle, hitting a chord, so it hits chord AB, at 90 degrees, then it automatically divides that chord into 2 equal halves. And the total length of the chord is 8, and so of course AC would be 4. So the reason, and the reason is very important, it's the line from center. Now are we going to say to the midpoint of the chord or perpendicular to the chord? What was the reason that allowed you to say that these two are the same? It's because you had the 90 degrees. So you're going to say line from center, perpendicular to chord. Now have a look in this triangle over here. Well, we could say that that angle C, so angle ACO, right? I can't just say angle C because that could be this one or that one. So I have to specify this one by saying angle ACO is equal to 90 degrees. Why is that one also 90 degrees? Well, we could say because of angles on a straight line, right? Because over here we've got angles on a straight line and we know that they should add up to 180, and so they would both be 90 and 90. So we'll say angles on a straight line like that. And so in that green triangle we can now go ahead and use Pythagoras, because we know that AO is 5. They told us that the radius is 5, and remember the radius is the distance from the center of a circle to any point on the outside. So that length is 5. We know AC's length is 4, and so we could use Pythagoras to find the length of OC. And so Pythagoras says that you always take the longest one and you make it equal to the two shorter ones added together. And so we'll say OC squared. And then the reason for that is Pythagoras. You have to mention that. Then you just go ahead and get OC by itself, and so eventually you should end up with a value of 3. And so the length of OC is 3.